There are mysteries of the heavens out there, and they never cease to amaze and perplex us. Black holes are the most mysterious and impressive of these baffling natural phenomena. Where does space end and time begin? Whence come these colossal objects in space? In this exciting video, we will try to discover the truth about black holes and all the mysteries they conceal. Are you prepared to stare into infinity? Before starting, like the video and subscribe to our channel so you never miss our future videos. And now, let's get started. In a cosmos that appeared to be dominated by stars and galaxies, astronomers once considered black holes to be a rare and mysterious phenomenon. Surveys of galaxies and black holes that extend to the farthest reaches of the universe have revealed a perspective that is fundamentally different from what was previously thought. Near the centers of the majority of the universe's largest galaxies are dust lanes and swirling gas clouds, both of which conceal the presence of enormous black holes. The mysteries of black holes continue to enchant scientists and astronomers, inviting us to go deeper and deeper into the unknown. These mysterious extraterrestrial objects have amazing characteristics that confound our current knowledge of the cosmos. Black holes are like a tapestry of mysteries that are just waiting to be uncovered. From the ravenous gravitational pull they exert to the mind-boggling impact they have on space and time, black holes reveal a wealth of information that has yet to be uncovered. Nothing, not even light, is able to escape the gravitational pull of a black hole because the gravity in such regions of space is so intense. This is what gives black holes their name. The equations of Einstein's general theory of relativity gave rise to the concept of black holes, which indicated the potential existence of these gravitational monsters. The existence of black holes has been solidified as a part of the fabric of the cosmos, as a result of the accumulation of evidence that has been accumulated over the course of time as a result of scientific observations and theoretical breakthroughs. The process by which black holes are created is without a doubt one of the most fascinating elements of these cosmic oddities. They are born from the remnants of enormous stars that have used up all of their nuclear fuel and are on the verge of collapse. When a star of this kind reaches the end of its life, it suffers a cataclysmic collapse that causes its core to implode under the weight of its own gravity. This happens when the star reaches the end of its existence. During the explosion of a star known as a supernova, the outer layers of the star are rapidly expelled into space, while the center of the star collapses to a point of infinite density known as a singularity. This singularity eventually evolves into the center of a black hole and is encircled by an event horizon, which is a barrier from which nothing can ever escape. The event horizon is a characteristic that is unique to black holes and indicates the location of the point beyond which there is no escape. When an object passes this threshold, it will be pulled into the gravitational pull of the black hole for all of eternity. The mass of the black hole dictates how much space the event horizon takes up. This distance is called the Schwarzschild radius. For stellar black holes, which are generated from the remnants of huge stars, the event horizon is relatively tiny and only spans a few kilometers in total distance. In contrast, the event horizons of supermassive black holes, which are often located at the nuclei of galaxies, can span a distance of millions or even billions of kilometers. The peculiar way in which matter and energy behave close to black holes is one of the things that fascinates and mystifies scientists the most about these mysterious objects. When objects get closer to the event horizon, they go through a process called gravitational tidal forces, which are characterized by extreme stretching and deformation of space-time. These tidal forces exert a huge strain on the matter that is falling toward the black hole, which causes the matter to elongate and become spaghetti-like before it is eventually swallowed up by the black hole. This peculiar phenomenon is a consequence of the tremendous gravitational gradient near the event horizon, which causes the fabric of space and time to become profoundly distorted. The event horizon is the point at which the gravitational gradient reaches its maximum value. A recent study has shed light on the possibility that black holes release radiation, despite the fact that the stuff that is falling into the black hole may appear to be doomed to be lost for all of eternity within the black hole. Stephen Hawking, a British physicist, first hypothesized the existence of this phenomenon, which is commonly referred to as Hawking radiation, in the year 1974. According to quantum theory, particles and their antiparticles are constantly being generated and destroyed in space. This phenomenon is called pair creation and annihilation. According to Hawking's theory, near the event horizon, one of these particles could fall into the black hole while the other escapes, resulting in a net loss of mass for the black hole. Even though it is extremely feeble, this radiation might be able to provide a way for black holes to gradually evaporate over the course of time. The investigation of black holes has also contributed significantly to the advancement of knowledge in the scientific discipline of astrophysics. Observations of stars around compact objects with enormous gravitational influences have offered solid evidence for the existence of black holes. These systems, which are known as binary black hole systems, display unique orbital dynamics, which can be observed by the gravitational interactions between the two black holes in the system. The groundbreaking discovery of gravitational waves in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO, provided additional evidence for the existence of black holes and introduced a fresh perspective into the investigation of the cosmos. An even more perplexing question is posed by the supermassive black holes that can be located in the centers of galaxies. These cosmological giants, whose masses might be anywhere from millions to billions of times that of our Sun, are essential to the development of galaxies and play an important part in the process. It is generally accepted that supermassive black holes grow by a process known as accretion, in which they gradually consume surrounding gas, dust, and even other stars. An accretion disk is formed as matter spirals into the gravitational well of a black hole. This accretion disk is a swirling disk of material that is superheated and produces powerful radiation over the electromagnetic spectrum. The energy that is released from these accretion disks can outshine entire galaxies, and the jets of particles and radiation that originate from the neighborhood of supermassive black holes can reach thousands of light years in length. The energy that is released from these accretion disks can even outshine entire galaxies. There is still no clear explanation as to where supermassive black holes come from, despite the fact that numerous hypotheses are fighting for acceptance within the scientific community. The direct collapse of enormous clouds of gas in the early universe is the premise of one of the hypotheses that attempt to explain how these behemoths came into existence. One theory suggests that they are the result of a series of smaller black holes merging, followed by the accretion of gas and stars. Another theory suggests that they are the consequence of a singular event. Understanding the mechanics behind the birth and growth of supermassive black holes is a major topic of research that is still being conducted today. This is because this information is essential to deciphering the intricate relationship between the evolution of galaxies and the black holes that reside at their centers. Black holes continue to provide problems for our understanding of physics, which pushes the limits of our knowledge and motivates us to investigate uncharted territories. When we look into the depths of these cosmic enigmas, we find that we are presented with profound issues regarding the nature of space, time, and the universe itself. Where does one find themselves after passing the event horizon? Are there any possibilities that black holes could act as passageways to other parts of the cosmos? How can black holes influence the progression of galaxy populations over time? These enticing enigmas compel us to set out on a path of exploration, one that brings together scientific investigation and technological advancement in order to solve the riddles of the most mysterious beings and objects in the cosmos. Thanks for watching. If you want more videos like this one, make sure to like the video and subscribe to our channel to never miss out on